All right, let's get started here. Welcome, everyone. I'm Dean Andrews. I'm Head of Developer Relations at InterSystems. And this webinar is to celebrate the winners of our InterSystems Python Programming Contest. We had 15 amazing applications submitted, and we're going to celebrate the winners here. Here is the list of our expert winners from the team in InterSystems, first through fifth place. We're going to do demos of these top 5. And we also wanted to say that there were community winners as well. They're all listed here on this page, which is available in the InterSystems developer community. Before I jump in to the demos with the winners, is there any overall comments from the InterSystems team that's on the call here? No? All right. Let's get started then. For the winners and the demos, please introduce yourself, describe your application, and give a short demo. We do need to limit the demos to 5 minutes because we have a whole set to go through and we are limited on time. So let's start with 5th place and with Yuri, the face login application. Is Yuri here?
I think Yuri is not here. Maybe he'll join later, but no.
Okay. All right. Then let's jump into 4th place with Andre and the Iris Python Machine Learn app.
And likewise, I think maybe something wrong with his internet in Brazil because both guys are from Brazil. So they're not here.
All right. Let's move right along to 3rd place. Is Lexi here?
Alexei said that he unfortunately is not able to join because it's a working day for him, and so it's he's technically not able.
All right.
Yeah, so maybe he'll join.
How about Muhammad? Is Muhammad here?
Mohammed is here.
Hello. How are you, Mr. Dean?
I'm great. How are you, Muhammad?
Okay, nice to see you.
Nice to see you as well. Yes, let's go with the Iris Gen Lab demo.
Okay, so can you see my screen right now?
Yes, we do.
Okay, so this is my application. It was basically it's Flask application, and it uses multiple technologies. Mainly, it uses this NLP and some of LLMs and some of the Flask login functionality as well. So this is the interface, basically Flask, SQL Chemi, and Flask login, and chatbot is using PyTorch. This is a famous Python library for machine learning. Then we have SPSI, this is NLP and Hugging Face, using pipeline here, GPT-2 for LLM, and Generative Palm API in Google Flan T5 XSL library as well, and ChatGPT OpenAI. So these are some of the features of the application. It's using user registration and authentications. This is using Flask, then chatbot functionality, then this name entity recognition. This is for NLP, and also I'm using PEX production to just call this NER from the production. Then we have this sentimental analysis, Hugging Face text generation using GPT-2 LLM, and then Google Palm API. I'm also using, this is also another LLM, and Google Flan T5XSL. This is also one of the model, and last is OpenAI. So the installation is simple. Just we have to clone the repository, and then we have to use Docker Compose up to build, and then up the repository. So this is our main thing here. We need some APIs. We need Hugging Face API and Palm API and OpenAI API. How to get it is already explained in this repository. So to start the application, we needs to Docker Compose, exec, run this command, and then we have to start our Python application, which I already started here. So the application is already running. So just I'm going to the main page. This is the main page, home page. So I am here in the home page. Okay, so I'm already logged in. So user need to be just sign on. If I just log out, I need to just sign up. Just we can sign up, and then we need to sign it again. So I already have a user. So I'm just signing again. So let me. Okay, so let's start with okay, let's start with the chat here. So all I need to just click this icon, so I can just chat with this application, say hi. So it's just I am getting the response here. So I can say, tell me about this app. So it will give you some detail about this app and what is NER. So it's giving detail about what is this name entry recognition. I can say thanks. So this is a simple chatbot. I already explained in my article all these details. But anyhow, this in the code there is a chat.py file. So from here I'm using all these details to retrieve this chat GPT. And basically this is a chat file, and I'm just saving this in this data file, and all is already explained in this in my article as well. So this is a file getting all the questions and generating the response based on using PyTorch machine learning language. So model is trained based on this data. So next we move to this named entity recognition. So I'm click here. I have to just type some text. I already just have this text here. So I'm pasting here and submit. So what it will do, it will just recognize the entities. For example, this is a person, this is organization, this name, and same, this is a flag, and this is a location, and this is a date. So these are the entity for this application. So here I'm using the model I'm using here, which is in the irs-script.py file. And thanks to Mr. Avagani for this template. This is the latest template for embedded Python application. So this is a basically model I'm using with SPSEY for this NLP.
Sorry, Muhammad, actually thanks goes to Guillaume Renier.
Yeah, also
Yeah.
both of you. For PEX, I'm using also for him. Thanks to both. And same, I'm using the production here. So the production. So this is a production here. I'm using the same functionality of LLM, and if you go to the message. So this is basically the message. This is the original message, the same text which I wrote here, and here I'm using here to just recognize the entities. For example, this is the name. It's saying this is a person, this is an organization, and this is a location. Germany is a location, and this is a date. So this is all here in the repository when we are using the production here. So this is all here in the, we have a process and operation. So this is all the PEX functionality. This I'm using another template here. So this is all is I mean this is a service basically I'm calling here in the production. This is NAR service. So this is the same service is calling and just getting the data, and this is a text. This is a text I'm passing to the process, and it's then moving to the production, to the operation. Okay, next we move to the sentimental analysis. So this is just any syntax, any sentence. For example, I like to play football. Is positive, should be positive. Yeah, this is positive, and this is a score, almost 100%. And if I say I dislike this, so it should be negative. So it's negative and almost 100%. This is what the sentimental analysis do. This is just part of NER as well. So next I'm using the text generation. This is a Hugging Face and GPT-2, this model I'm using here. This is the LLM GPT-2 by using Hugging Face. So text generation, I'm writing some text, submit. So it will generate the text related to this sentence. Okay, so it's generated some text. Machine learning is great community, it helps. Then from here, it's generated the text related to this sentence. So this is just related to machine learning as well. So next we move to Palm API. This is again Google large language model. Using Palm API, we can ask what is Palm API. So the submit, and it will just use this LLM to generate some text. So this is a basically generated text, Palm API. So these are details related to Palm API. Next, we have another model from Google. This is Google Flan PS XSL. Here we have multiple things we can do. For example, we can ask a question, and we can ask the rationale as well. So I'm saying this is a question. This is a question is I have a conversation with him. So let's see. So it's saying George Washington died in 1799. So it gives the detail, the rationale against this question. We can also use to translate this. I can say translate to French, and my name is Waseem. Okay, submit. So it will translate to this language. It's running. Let me see if something, because last time I consumed all this. Okay. But anyhow, this will, I mean, this will translate to any language. So we have multiple languages. Okay, so at the end we have, I'm just stopping this one. Maybe sometime it's stuck. Maybe I don't have the key. Maybe it's not working properly. And at the end we have OpenAI. This is OpenAI Chat GPT. You can say, give me capital of UK, for example, any question. So it will just return the response here. So the capital of UK is London. So this is all, I mean, the functionality here. Just quickly, I just go through to the code. So this is basically the main file is here. This is a views.py basically. So this is a Flask application. So this is a basically main code is here. For NAR, it's using this model, which I already explained. I downloaded this in the script file by calling this functionality by this SPSUI. So it's using this model to generate this NLP based on the text which I am passing here with this request, and then it's rendering to this template and is displaying there. Same with the sentimental analysis. This is also I'm using this pipeline, and this pipeline is for the transformers, and this is from the Hugging Face. So then I'm just using pipeline and passing this text, and it's returning the result. For this GPT-2, I'm using text generation and GPT-2 model again from the Hugging Face. And then this is Google Bard PALM API. So I'm passing the key, which is stored in this myconfig file. So I'm just initiating this PALM API and passing the value and generating this with the chain, and then I'm passing this value to this template. Then we have Google LangChain Hugging Face. This is GFLAN. Same thing. We need to pass the token for Hugging Face, and just creating our template and passing to this file, passing to the Flask, which will just display this there. And at the end, we have OpenAI. We have to need the OpenAI. I'm initializing here the API key. This is the environmental variable, and then I'm just generating this chain and passing this text, and it will get the result back and pass to this HTML, and it will generate there. So that's it.
Great work, Mohammed. Congratulations. Any comments from the team online here?
Salam, Mohammed. This is Guillaume. I do have two questions for you. First, do you think that's an added value to have now this iris script p file? Does it change? Does it help you to have some kind of Python first approach even to build our containers?
It really helped. Yeah, it really helped. Basically, I combined here two templates. One for embedded Python, one is PEX. And thanks again to you for these great templates. So it really helps, and it really made my life easy. I just need to just get some, the idea and just implement it here, and template was already there. So thank you very much.
Okay. And do you see yourself using the PEX production in Python in your daily life? I mean, as a developer or as a manager?
To be honest, still it's not as easy to use PEX functionality in our current application. Still a little bit complications there, but better than before. It looks like it needs some more to make it more easy. Still, it's difficult to implement the same things here the way we are doing.
Why? What are you missing?
It's not very straightforward. It's not like plug and play. We have to just modify a lot of things to just follow to use the same, the way the message is passing to the operation, and from operation is going to there. So still, it's okay, but it's not very straightforward. Still, we have to just work on it.
Okay, so we have to improve the user experience of PEX.
Yeah. Otherwise, it's fantastic. Yes.
Okay. Thank you for your feedback, and great job.
Welcome. Thank you.
Any other comments from the team?
Muhammad, I have a question. Actually, yes, this is really amazing. One maybe silly question. So it's great that we have so many different engines, but maybe one engine, the GPT, just does that all the rest do. I mean, maybe we need just only one.
Yeah, yeah, you are right. But it was the idea behind was is to just combine multiple things, and we can say we can use this with Iris, these kind of things.
Yeah, but this is really fantastic. And what actually I like personally, besides all this AI exercises, the login thing via Flask. And my personal request, if you could just publish just login part, like a standalone package that you install it and you have a login application like registering users via Flask for any Iris application, just kind of standalone. It's a really important component for a lot of applications, especially within a combination of Python with Iris.
Okay, I'll communicate with you for this.
Yeah. So
Nice
just
idea.
like my personal, but thank you. That was pleasure to see how easy is that, and how handy Python Flask with Iris with all this, and that uses also SQL Alchemy, I believe, as I'm not mistaken.
Yeah, yes.
Just one question about the logging. Are you storing the user in Iris?
Yes. Yes,
Yes, you are.
yeah. It's in the table, user table. It's already there in
Okay.
my repository. The last part I already explained. There is the user table is there.
Oh, great. Yeah.
Awesome.
Thank you.
Okay, welcome.
I don't think Yuri or Andre joined in the last few minutes. Is that right?
Maybe Dean, can I have yet another like comment? So it's speaking of configuration. So this is great that you put this configuration file, but also maybe you could examine what Alexei did with his Iris record helper. He even managed to put this API codes into automation. So if you deploy, this will be, so you can deploy through GitHub secrets. So you can put API key in a GitHub secret, and this will be used in like a demo deploy. So and still it uses also config, but this is just one handy thing that a lot of developers could follow, like deploying their own applications with this keys.
Yeah, you are absolutely right. Otherwise, if we publish like this, straight away we get message that you expose the key. So
Yeah, exactly.
So, yeah. Okay, that's a nice idea.
All right. Then let's jump to Dmitry with Iris Vector.
Okay, hello everyone. Let's share the screen. So I have a few slides. So what is vector? Vector is basically just a list of or array of numbers that can be integers, negative, positive, floats, or whatever. Just list of numbers. And this vector represents like any image, audio, text, whatever we want to use to index, to store as a vector. And how it usually works, so with using some external packages like on Python and so on, from already pre-trained models, pre-trained for some specific type of data, like for audio, for text. Text can be different, like it can be in different languages, or it can be like different, like it's Wikipedia thing, or like it will be science papers and so on. So models can be different, and pictures, videos, or whatever we want to use in our scenario. Then so we have this pre-trained model external. Then we have some binary data or in our database. So we can calculate one vector per this version of data with this model, and now store in Iris with support of vector. For vectors, it's important that we need to calculate distances. There are few different algorithms how to do it. They do it differently. Results is different. So depends on needs, depends on your data. You just select which distance you want to use in a particular scenario and use it. And very important part, unfortunately, I didn't manage to finish this part completely, is indexing, because we can store index vectors in database, but for main reason is to search data in this index. So we have like thousands of vectors, millions of vectors stored in our database. We need to find by new query, find the closest by distance some list of vectors. And to make this happen, so use all the vectors and store it and calculate distance to each of a vector is quite complicated thing. It will take a lot of time. So index will help to make it faster. But index for vectors is also quite complicated thing. As you can see, so it's a first step, like we add one vector, add another, we calculate distance, then we add one more vector, again calculate distance, and so on and so on, and we add link only to the closest distances. And by but we have parameters such as like each vector can be connected to like maximum some vectors. Recommended is like around 50 vectors only you can connect. And here how the search working. So in addition to just have this linkage, because we have a limitation of how many links we can have between vectors. So when we manage to hit this limit, we have to move points, these vectors up on layers, so we can spread them on a bigger amount of layers. And the same vector will be linked to different points to different vectors on each layer. And when we search, we go in from the top layer, search for closest entry points. So it will be entry points. We have, so it's expected to be also parameterized how many entry points we're going to use. So we search closest, then we go next, use them, search for vectors closest to the search query, and so on, going to the latest layer. But So with indexing, we store these links. We already during indexing calculate distances. So index is fixed to the algorithm of distance, and with this help a bit faster, much faster to search for new query. And another algorithm expected to be even more faster. I didn't try to implement this one yet. It's an inverted file index. In this case, a bit more complex because it requires to calculate the center of some vectors. So it goes through all the vectors, search the centers of the vectors, and also it has on a different layers. So as you see, small portions of vectors with their own center, and bigger portion so is have center of those centers. So we can have it makes kind of like a tree, so we can go from a highest center and go deeper and deeper until we finish on the smallest region and find closest to the query. So I didn't manage, unfortunately, to finish due to some issues, yes, I found as requested by the contest. So we would need to report some bugs. So this reports are only mine, in fact. So this is realization. So we have here, so it's a type, quite straightforward. So the thing is, so to store the list of numbers, I just store it as a list build. So I need to convert it from kind of textual view from SQL to internal storage. So it just converts from textual to list build. Then so I have this bunch of functions which require to work with it. So yes, as I said, so it's L2, it's Euclidean distance. Due to Python, so I needed to convert list build to Python. It wasn't so like Pythonish way, so we still need to call it object script way. So I would expect like Iris embedded has this function directly, but okay. And also the issue is that it's only one way go, so we can't convert it back from list build to from Python list to list build. In this case, I used again with Guillaume's help, used his library for LB. So Euclidean distance and cosine distance. So due to again the bugs, I found I needed to implement it both in ObjectScript and in Python, because in some scenarios Python SQL functions written in Python didn't work if we trying to use multiple layers of like using from embedded Python call SQL in Iris, which uses embedded Python SQL. So it didn't go well as I wanted. It fails a bit. But so we have this L2 distance, cosine, again, as well as inner product is additional distance, simple also. And few other functions like sum two vectors subtract one vector from another, multiply. So just simple mathematical functions. But for vectors, it's also expected that it would have aggregate functions. I could do some, so I can, for any numeric numbers, I would do sum for value. But in case, no, it's not here. Yeah, right here. So I have aggregate vector sum, which iterate over using vector added. So it should return the same vector, the same dimensions, but InterSystems Iris SQL seems not expected it, so it always returns trying to convert it to numbers. So yeah, basically we can create table like this. So we have to define vector type with dimensions, which is fixed amount per field, and add it in textual form as implemented, or it can accept plain list build as well. But for a view, it always displays it as in textual form, at least in ODBC format. So small normalization function is just creates number. So what we have also, distances is here. So yeah, some, as I said, numbers will be different. So for even like L2 shows this one is the closest and goes like this. But if you look at cosine distance, it shows a bit different distances. So works depends on what is your data represents and how you want to have distances. Yeah. So for index, I wanted to use functional index. Yes, started, implemented it on Python, moved then to Python from external file. Also, there are few mathematical functions and so on. In Python embedded it like a bit more clean, looks like, because yeah, I use here this dollar list from Guillaume, which helps. I've wrapped it a bit to make it even more usable for this scenario. So I can calculate distance Pythonish way with just I pass my list from Iris form, and it calculates distance for me. But also when I needed to store to Iris distance, again found a bug. So but yeah, I think I just took too big task for me, because yeah, it's quite a big task. This algorithm is very short. It's supposed to be like 3 times or 4 times bigger to make it really working as is expected. So it requires a lot of work and testing to make it happen. And also due to the structure of stored index in format like this graph, so needs testing how it will be in performance, how fast it will read, how it will go with B3 storage, how is in our database. So kind of like this.
Thank you all for participating in this contest. For those watching on YouTube or social media, you can find all of these repos in open exchange on our developer community, InterSystems developer community. We do programming contests with prizes like these every other month. So join our developer community at developer.intersystems.com, and you can find out about the next contest and hopefully join us and participate. Thank you all, and have a great day.